You should have your calculator. Now, today and the next time I see you, which will be next Thursday, I only see you once next week. You're going to be learning some formulas. And these formulas are going to be the formulas that are going to be on that memorization quiz. That's quiz number 13. One set of the formulas that you're going to be learning is what are called trig sum and difference identities. These are not hard at all. Besides learning the formulas and how to work with them, there is one big thing I want you to take away from this lesson, and I'll explain that in just a minute. I want you to take a look right here. We're going to be looking at that expression, sine of 45 degrees plus 60 degrees. Now, first of all, make sure your calculator's in degree mode. If it's in radian mode, you're going to get bad answers. Now, here's the question. Does sine of 45 degrees plus 60 degrees equal the sine of 105 degrees? Now, don't use your calculator yet. Would you say that's a true sentence or a false sentence? You think that's true. Why do you think that's true? Because 105 is the sum of 45 and 60, okay? Do you think that that is equal to the sine of 45 degrees plus the sine of 60 degrees? Just distributing sine. Okay, why are you vigorously shaking your heads? No. How do you know? Because you've already used your calculator? Okay. Now here's what I want you to do. I want you to do 3 operations on your calculator and don't erase, don't clear. I want you to put this on your calculator, figure out what it is, then this, and then this. And I want you to tell me which ones are the same. What is this one? 9659, so 966. What's this one? 0.966. What's this one? Now, we know which 2 are the same. So what this tells us is that this is not equal to this. What does that tell us that we cannot do in trig? Now, never, you write this down, and you can write it big because you're not going to write anything else in here. Never distribute a naked trig function. Never distribute a naked trig function. You may be thinking, I don't know what a naked trig function is. Do you remember I told you that when you wrote like sine, when you write that by itself, it means nothing. The sine of what? Oh, the sine of pi over 4. Oh, the sine of 30 degrees. But sine by itself means nothing. That is naked. That means nothing. You can't distribute that. Because sine by itself doesn't mean anything. Why are you doing this? Does it help you see better? Well, all right then. That's fair. Okay. Just curious. So that right there, that's what I need you to take out of today. You cannot distribute a naked trig function. I could distribute the sine of 45 degrees. That's a number. That means something. Sine by itself or cosine by itself or tangent by itself doesn't mean a daggum thing. You cannot distribute that. All right, let's move on. Now, there are formulas I want you to take a look right here. That looks like something you would want to distribute, right? But you can't because that sign out there is naked. So the question is, so how would we do? How would we do this when we maybe can't add those together? Or maybe when we do add them together, it gives us something that we don't know anything about, like 12 degrees. Well, I don't know. Now, we got a formula here. And the formula here says that the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. So what we're going to do is we're going to use that formula to do that. Now here's what I would contend to you. Now hang on a minute. When you add those up, you get 105 degrees. I see one of you has it close by. Can we pull this out for a second? Thank you. I would strongly encourage you to get out your stuff you must know cold piece of cardstock. If you add 45 degrees plus 60 degrees, you know you get 105 degrees. Is 105 degrees an angle on your stuff you must know cold? Nope. So we have no way to know exactly what the sine of 105 degrees is. However, we have a formula that we can use because we know 45 degrees and we know 60 degrees, and those are angles that you know about. So let's talk about the way for you to, what are we going to put everywhere we see an A? What's in the place of A? 45 degrees. And everywhere we see a B, what are we going to put? 60 degrees. So here's the way we're going to do this. Let me make myself a little more room here. Now I'm going to show you, I'm going to say how I think through this formula, okay? It's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Whoops. As we go through these, you will pretty quickly be able to learn these formulas. They're not hard. All four of these pieces are pieces that you know because you took 3 memory quizzes on them, right? Oh, well, maybe. What's the sine of 45 degrees? Square root 2 over 2 times 1/2 plus square root of 2 over 2 times square root of 3 over 2. Now, what is square root of 2 over 2 times 1/2? Square root of 2 over 2 over 4. What? Square root of 2 over 4. Yep. So this is square root of 2 over 4 plus square root of 6 over 4. Oh, I have a common denominator. So that's the square root of 2 plus the square root of 6. Right, I can't combine them into square root of 8 or something. Right, I cannot do that. That, ladies and gentlemen, is the sine of 105 degrees. Exactly. Now here's what I want you to do. I want you to go back to your calculator and I want you to use your fraction feature. And I want you to type in square root of 2 plus square root of 6 all over 4. Remember, when you use a calculator on these, you're going to get you have to round, right? So this is just a way to find exact values for some trig, for some angles that we typically wouldn't know about. Now we're going to look at these bottom two on this page, and you may want your stuff you must know cold. Find the exact value of the sine of 15 degrees. 15 degrees is not on our unit circle. We don't know anything about it. Using two angles from the unit circle whose difference is 15 degrees. Can you come up with two angles on that picture that will subtract to give you 15 degrees? 45 and 30. What else? 60 and 45. You bet. You could use either pair. You could use either pair and you'll get the same answer. So here's what I'm going to do. I'm going to use what Carlos said. I'm going to do 45 degrees minus 30 degrees. Now, if you'll notice here, you notice we got a minus in the middle. So we're going to use this one that's got the minus. Now, the sine of the first times the cosine of the second. Now, how do I know whether it's plus or minus? When these trig functions are different, this is going to stay the same. Minus cosine of the first, sine of the second. All four of those pieces we know already. What's the sine of 45 degrees? Square root of 2 over 2 times square root of 3 over 2, good, minus times, good. Now just clean it up a little bit. What's that going to give us? Square root of 6 over 4 minus the square root of 2 over 4. So that's going to equal square root of 6 minus square root of 2 all over 4. And that's the exact value of the sine of 15 degrees. You would have gotten exactly the same thing had you done 60 degrees minus 45 degrees. You'd have gotten exactly the same answer. Let's try the third one. Find the exact value of the sine of 285 degrees. That is not on your circle. Using two angles from the unit circle whose sum is 285 degrees. Find two. $150 and $135, that'll work. Sine of 150 degrees plus 135 degrees. Did anybody else find another pair that would have worked? 240 and 45 would have worked. Good. No, as long as they're on that circle and they'll add up to 285. I don't care what they are. 163 is not on that unit circle. Sorry. Good try. All right. Now, when I have sine, my trig functions are going to be different. So this plus minus is going to stay the same. You got to figure out a way. Now, you're like, I've been doing this for 5 minutes. You're telling me to learn it? Yeah, just learn it by the next quiz. Okay, so sine with a plus. It goes sine of the first times cosine of the second. Plus or minus stays the same. Cosine of the first, sine of the second. Now, methinks we're going to have to go over to a circle and figure these things out. Let's talk 150 degrees. What quadrant? Quadrant 2. What's the reference angle? Good. So what is the sine of 150 degrees? Square root of 3 over 2. Good, because it's the same as the sine of 30 degrees, right? And quadrant 2 is sine positive or negative. Sine goes up, right? Up and down. So square root of 3 over 2? No. Did we say square root of 3 over 2? It's a half. It's a half. What's the sine of 30 degrees? Sine of 30 degrees is a half. Yeah, so it's a half. We'll get to that in a minute. Let's do everything that we got to do for 150 degrees. What's the cosine of 150 degrees? Square root of 3 over 2? Negative because it's going to the left. Times, and we'll deal with 135 degrees in a minute. You okay on the 150 degrees? Okay, let's go to 135 degrees. What quadrant are we in? Yep. Reference angle? 45 degrees, good. What's the cosine of 135 degrees? What's the sine of 135 degrees? Good, good. What do we got? Multiplying, right? Square root of 3 times the square root of 2 is square root of 6, right? So this is negative root 2 minus root 6 over 4. Was that the second one? Yeah. Okay. That's all we're going to do with sine. Question? If the reference angles are some combination of 30 degrees, 45 degrees, and 60 degrees, right? So most of them will. Oh, I said I lied. That was not the last one of sine we're going to do. Okay, let's try this top one. Now notice we've got an X. That's okay. See if we can, let's try to talk through. That's a sine of two angles that are added. So it's going to be sine of the first, cosine of the second, plus or minus stays the same, cosine of the first, sine of the second. It'll take you a little bit of time, but you'll get used to the formulas. So that's going to be sine of x times whatever the cosine of 2 pi over 3 is, plus the cosine of x times whatever the sine of 2 pi over 3 is. Yes? All right. Where's 2 pi over 3? What's the reference angle? That's 2 pi over 3. How much we got left? What's the cosine of pi over 3? Say again? Right. It's 1/2, but you go left, so negative 1/2. Do you have questions about the numbers? Now here's how I want you to write the answer. I want you to write the numbers first. I want you to write negative 1/2 sine x plus root 3 over 2 cosine x. This is kind of standard form. And I hope what you're thinking is, well, as long as I can remember the formula, I know what to do. It's not hard. Let's go to B. Yeah. Yeah. What else are you going to do? What? I don't have an equation. I can't solve for x. I don't have an equation. There's nothing on the other side of that equal sign. It's been a long week. It has been a long week. Yeah. Let's look at the second one. All right, sine, and we got a minus in between those two angles. Sine of the first, cosine of the second, plus or minus stays the same. Cosine of the first, sine of the second. The way I'm saying it out loud is how I remember it. You find a way for you to remember it. What's the sine of pi over 2? That's 1. That's 1. What's 1 times cosine theta? So that's cosine theta minus, that's just 0. What's 0 times sine theta? 0. Yep. I like that one. Let's go to C. We're going backwards. We're going from what we had over here back to here. Our trig functions here are different, so we know it's sine. We also know it's sine because that's the only one you've done. What are the angles? Why is it a plus? Remember that the plus or minus stays the same, so that's a plus. So, well, what is this? Well, this is the sine of 90 degrees. Oh, snap, I know what the sine of 90 degrees is. That's 1. That's 1. Same idea on the next one. Again, we're going backwards. Trig functions are different, so I know it's a sine. The angles are 290 degrees and 50 degrees. It's a minus because the plus minus stays the same. So this is the sine of, don't really need that, 240 degrees. Oh my goodness, I believe I know something about that one. Quadrant. Oh, go look. What quadrant is 240 degrees in? Reference angle. 60 degrees, good. What's the sine of 60 degrees? Sine of 60 degrees. Negative square root of 3 over 2. Negative square root of 3 over 2. And that, ladies and gentlemen, is everything you ever wanted to know about the sine sum and difference formulas. Let's talk a little bit about cosine. When you're doing the cosine, come on. When you're doing the cosine of a sum or the cosine of a difference, then here we go. Put your phones away, please. We're just not even gonna do what it says. It says do the nearest thousandth, yada yada yada. We're just gonna do it, okay? Now, are we going to use the formula highlighted in yellow or the formula highlighted in green? Why yellow? Because it's a plus. Now, if you'll notice on the cosines, Yeah. What do you notice about these? Those stay the same, don't they? Looks like we got the measles right now, though. All right. What am I going to put in the place of A? Pi over 6 and B? Pi over 2. So it's cosine of the first, cosine of the second. Oh, but if the trig functions stay the same, then the plus minus changes. Sine of the first, sine of the second. What's this? What's the cosine of pi over 2? What's the pi over 2? Not pi over 4. That's 0 times whatever that is. I don't care. That's 0, right? What's the sine of pi over 2? That's 1. What's the sine of pi over 6? 1/2. Sine of pi over 6 is a half. What's my answer here? 0 minus a half? Negative 1/2. Okay, last one on this page. Here we go. Cosine of, whoops, didn't need that. Cosine of the first, cosine of the second. When the trig functions stay the same, the plus minus changes. Sine of the first, sine of the second. Now I know everything there is to know about 45 degrees, but I got to think about 120 degrees. Good. 120 degrees is in the second quadrant with a reference angle of 60 degrees. Good. So what's the cosine of 120 degrees? Goes to the left, so it's a half. I mean, it goes to the left, so it's half. Goes to the left, so it's negative. What's the cosine of 60 degrees? It's a half, so negative half. Cosine of 45 degrees? Square root of 3 over 2, good. Good. So what have we got? Can we just do all this as over 4? Plus what? Good. You have questions so far? You finding this fairly easy? What does... Hmm? Cosine, the plus minus changes. That's why. Got giggles today. A little bit. Tangent, last one. Now, you got a fraction, but it's still not terrible. They're still pretty easy formulas to work with. Find the exact value of the tangent of 75 degrees using two angles from the unit circle whose difference is 75 degrees. Can you find a pair whose difference is 75 degrees? 120 and 45 will work. You buy that? All right, so this is a minus, so we're going to use this one. So we've got tangent of 120 minus the tangent of 45, and this is degrees, over 1 plus tangent of 120 times the tangent of 45 degrees. So if you'll notice, the top, that sign stays the same on the top, but on the bottom that sign changes. What's the tangent of 45 degrees? 1. Good. Tangent of 120 degrees. What are the coordinates right there on the unit circle for 60 degrees? This is not drawn to scale at all. There you go. So what's the tangent of that angle? Square root of 3 over -1, right? Because when you do this, the 2's would divide out. They'd factor out. So that tangent is negative square root of 3. So what we've got is negative square root of 3 minus 1 over 1 plus negative square root of 3 times 1. So that gives us negative square root of 3 minus 1 over 1 minus square root of 3. Are those exactly the same where I could factor them out and say answer's 1? Where do you see a difference? Where do you see something different? That's right. Numerator is a -1, but denominator is a +1. Good. Okay. Yeah, y'all are doing well. Yesterday's class had, I don't know, something was in the water or there was a full moon or something. Yesterday's class was a mess. Yeah, I know everybody's tired, I know. Okay, right here. Find the exact value of tangent of 165 degrees using two angles from the unit circle whose sum is 165 degrees. Okay, fine. 120 plus 45. Tangent of 120 degrees plus 45 degrees. That's nice because we already know those numbers, don't we? So here we go. Numerator is going to be tangent of 120, same sign. Tangent of 45 degrees divided by 1, different sign, times tangent of 120, tangent of 45 degrees. All right, what's the tangent of 120 degrees? Did we get negative square root of 3? Yeah. Plus 1 over 1 minus times 1. So that cleans up to give us negative square root of 3 plus 1 over what? 1 plus the square root of 3. There you go. What you got? Don't. No, go ahead, please. I believe we have one more on this page. Is that correct? Okay. Now, I'm just going to tell you right now, this is one of my favorite kinds of problems right here. Suppose the sine of theta is 3/5 and the sine of alpha is 5/13. Additionally, the tangent of theta is positive and the tangent of alpha is negative. Draw angles theta and alpha, labeling the reference triangles. We're going to stop right there. We need to draw those two triangles, those two angles, and make the reference triangles. You've done that. Now, If you remember, we're going to go through this kind of quickly. The first thing we got to do is decide what quadrant the thing's in, right? So let's talk just about theta. What does this tell us about quadrants? The y value is positive, which occurs only in quadrants 1 and 2. So we also know this. What quadrants have a positive tangent? 1 and 3. What quadrant is theta in? Theta is in quadrant 1, so let's draw theta. So all I know right now is I'm just going to draw a reference triangle in quadrant 1. There's my theta. And we're going to draw it based on this fact right here, that the sine of theta is 3/5. How do we do that? How do we show 3/5 as to be the sine of this angle? You've done this. Opposite over hypotenuse. Sine is opposite over hypotenuse. So what's opposite? 3 hypotenuse. 2, 1, right? No. We've got theta drawn, and we've labeled the reference triangle. Now let's go to the same thing for alpha. So what do we know about O alpha? I know the sine of alpha is 5/13. What quadrants could alpha be in? 1 and 2. And I also know this. Tangent is negative. Where? Where's alpha? Alpha's in quadrant 2. So we're going to go over here and we're going to draw a little alpha. There's alpha. The sine of alpha is 5/13. Where do I put numbers? 13 is the hypotenuse. Good. Sine is opposite over hypotenuse. Opposite hypotenuse. -12 because we're going left. Yeah. -12 because we're going left. This is stuff, this is not new, right? You just may have forgotten it. Had you forgotten a little bit? You think what? What do you think? You may. You may. Now, the sine of theta plus alpha. All right. Let's get on the stick here and let's see what we can do. The sine of theta, I'm going to scoot over. Now what we got to do is we got to know the formula. The sine with a plus, sine of the first, cosine of the second, trig function, or plus minus stays the same, cosine of the first, sine of the second. And we're going to pick those values right off the two triangles. What's the sine of theta? What's the sine of theta? 3. So what's the sine of theta? I know you're tired, but give me 10 minutes. 3/5. 3/5. I'm tired too. I'm exhausted. I know you are too, but what's the cosine of alpha? -12/13. Good. Plus the cosine of theta, 4/5 times the sine of alpha. Now here's what I don't want you to do. Don't look there and be so excited that the 5's will factor out and this is 4/13, because you have to go back and get another common denominator anyway. You've already got common denominators, don't you? Yeah. So don't screw up a good thing, right? So what's this give you right here? Negative 36/65 plus 20/65 equals negative 16/65. There you go. No, well, we're not finished. It told us to find 3 things, didn't it? How about we just find 2? How about we do that one? Tangent of alpha, theta minus alpha. Tangent of theta minus alpha is tangent theta minus tangent alpha over 1 plus tangent theta times tangent alpha. Now those tangents better be so easy to find. What's the tangent of theta? 3/4 minus, what's the tangent of alpha? Negative 5/12 over plus the tangent of theta, which you said was 3/4, right? Times the tangent of alpha, which you said was negative 5/12. And your brain screams just a little bit because you're thinking, I got fractions. Yeah, but it's not a big deal. Look at the numerator. What's your common denominator up there? What's that? 9/12 plus 5/12. So that's 14/12, which would simplify to 7/6. So that numerator is just 7/6. 1 minus. Yeah, I just went ahead and did the minus because I saw a minus right there. What's that? Over 48. This is 48/48. What's that give you? Good. So this is 7/6 divided by 33/48. So times 48/33. Does that sound good? Yeah. (56/33). You will see problems like that on the quiz and test. I'm just going to tell you, where you have to draw those triangles. So please work those enough where you get comfortable. Okay. Now, I think we're going to work 2 of these. This one right here will for sure be one of them. Please notice this says verify. Now we've got an equation, okay? And when it says verify, what has to go up? The Berlin Wall. And remember, the Berlin Wall is vertical. Had somebody yesterday or in the other class draw their Berlin Wall horizontally and did the left side above it and the right side below it. Trying to grade was difficult. So make the Berlin Wall go this way. Now you may look at the right side and say, well, the right side looks more complicated, and in many ways I would agree, except on the right side I don't have any idea what I'd do. And the left side, I have a formula, don't I? Tangent of something plus something. If you have a formula, apply the formula. So remember, Berlin Wall's going up. I want you to write your work down, okay? And be thorough with your work. Please don't tell me on a quiz, but I did it in my head. I can't see what's there. I can't grade what's there. You got to write it down. All right, so we got a tangent with a plus. So it's tangent of x plus tangent of pi over 4 over 1 minus tangent x times tangent of pi over 4. Now we're going to go below. I don't know what the tangent of x is because I don't know x. So I just leave tangent of x as tangent of x for right now. What's the tangent of pi over 4? 1. Oh. So what I've got here is tangent of x plus 1 over 1 minus tangent of x. Well, okay. Now I got to make that look like this, right? Well, I guarantee you one thing. I got to change everything to sines and cosines. So let's change everything to sines and cosines. And listen, if you write this, I'm going to have fit. They're naked, okay? They're not coming out of the house. You put the x plus 1 What do you think we ought to do right here? Yeah, so I'm going to simplify the top by doing a common denominator of what? So what have I got? What's all this top clean up to? Sine x plus cosine x over cosine x. Yeah, yeah. So sine, that whole thing cleans up to sine x plus cosine x over cosine x. Are you okay that that is what we just wrote down in purple? Now we're going to clean up the bottom. What's our common denominator? So that denominator is what? Good. What should we do with that? Yeah, so we're going to multiply by the reciprocal of this denominator. So it's going to be times. Now, I'm going to mark this out once I actually multiply by it so you don't have all that, because that all together would be flat out wrong. Cosine x minus sine x. Oh. Yeah, the angels start singing right there, don't they? So what are we left with? Well, we're left with sine x plus cosine x over, and I do believe that's what we were looking for. Dang, we had several steps there, didn't we? I know it's Friday afternoon. I know it's long. I know. Let's go to this one. upper right corner. Tangent of pi over 2 minus x. We've got a formula for that, right? First of all, I'm going to ask you, are we on the left? Does that say what is the tangent of pi over 2? No, it doesn't. It says what is the tangent of pi over 2 minus something. So I'm not actually taking the tangent of pi over 2, right? All right, so apply your formula. That's tangent with a minus, so that's tangent of, can I tell you don't write this down? Why not? Just give me a second. Don't write this down. Tangent of pi over 2 minus tangent of x. I can erase faster than you can. Over 1 plus tangent of pi over 2 times tangent of x. No, I'm going to just use the black here. Where's pi over 2? Positive y-axis, right here. What are the coordinates on the unit circle? What is the tangent of pi over 2? Undefined. Undefined. No. Up here, is it asking me to take to find the tangent of pi over 2? No. So what I'm saying to you is, all this tells me is that I cannot find the answer to this question this way. It won't work. Yeah, so I'll just despair. So you say, well, snap, I don't know how else to do it. Yeah, you do. Now you can write. Because I know tangent is sine over cosine. Yep. Now we're going to use two formulas. Now listen, what you're going to do is you're going to do your two formulas, one on the top and one on the bottom, and you're going to clean them up. And it's going to simplify to that. Now, look right here. Look down here. This down here is simplify. You're going to use a formula here, add them together, simplify, okay?